Now let's look at this problem number 44 for chemistry past question 2018. Which of the following electron configuration represents the transition element chromium with atomic number 24, Cr24? Is it A, 1s2, 2s2, 2p6, 3x2, 2p6, 4s2, 3d4? B, 1s2, 2s2, 2p6, 3s2, 3p6, 3d6. C, 1x2, 2s2, 2p6, 3s2, 3d4, 4x1. D, 1s2, 2s2, 2p6, 3s2, 3p6, 4x1, 3d5. Now for us to solve this, we need to take note of the atomic number of Cr, which we are given very clearly as 24. So anything we are adding up in our checking, let's check for the first one. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. Once we add all these exponents, it must equate 24 for it to be close to the answer. So let's add for the first one. We have 2 plus 2, this 2 plus this 2, plus 6, plus 2, plus 6, plus 2, plus 4. What do we get? 2 plus 2 is 4, 4 plus 6 is 10, 10 plus 2 is 12, 12 plus 6 is 18, 18 plus 2 is 20, 20 plus 4 is 24. So we already have this. So we already have this 24 for chromium. But having that, is that enough to be the answer to this problem? Now, if we check for this other one, we have 2 plus 4, 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 6, 18, 18 plus 6, we also have 24. So can we say that this is now the answer? No, we cannot, because the electronic configuration has to be as after the s orbital, 1s orbital, you have to see the 2s orbital, then the 2p orbital. After the 2p orbital, you see the 3s orbital, then the 3p orbital, then you see the 4s orbital. And that is not the way it is here. Here you have 1s, 2s, 2p, 3s, 3p, 3d. Before the 3d orbital, as we have here, before this very 3d orbital that we have here, we are supposed to have 4s. It's missing, but it's here. So checking that here now also, before you get to 4d, 4s orbital must have up to 2 electrons, but here it's having only 1. So this is wrong. This is supposed to be 4s2, so that this one will be lesser, as we have here. And also here, after the 1s you have 2s, after the 2s you have 2p, after 2p 3s, after 3s there has to be 3p first. There has to be 3p and then 4s before the 3d. So this is also wrong. So this is the one that follows the rule that says that you must have 1s and your 1s must have up to 2 electrons before you move to the next orbital, which is 2x. All the s must have 2 electrons. Then you now move to p, 2p, and p will be having maximum of 6. Then you move to 3x, x is always 2, that is the maximum, p is always 6. Then after that you can move to 3p that has maximum of 6 too. Then after that you move to 4x that has maximum of 2, and then 3d to fill out the remaining. In this case we have 4. So that's how you move when you are calculating the electrons in electronic configuration. So A is the perfect answer for this. So you can see this under electronic configuration Thank you.